In this video, we're going to look again at a pulley system that has two blocks on either side, and we're going to solve for the acceleration of the system, and then we're also going to solve for something new. We're going to look at the tension in each of the strings as the system is moving. So we're going to call this side T1 and this side T2. In order to solve for both of the tensions, we must first solve for the acceleration of the system. If we look at both blocks, since this has a mass of 3 kilograms, its weight is 3 kilograms times 10 meters per second squared is 30 newtons. 2 kilograms times 10 meters per second squared is 20 newtons. So one force is pulling on one side, another force is pulling on the other side. Even though both forces are pulling in the same direction, the net force is going to be the greater of the two. So it's going to move, I would say clockwise to the right, because that's where the more mass is. So the net force is 30 newtons minus the 20 newtons is 10 newtons. And to solve for the acceleration is the net force divided by the total mass. So 3 kilograms plus 2 kilograms is going to be 5. So 10 newtons divided by 5 kilograms, acceleration equals 2 meters per second squared. All right, so we did the first half. Now, if I'm looking at the tension in T1, the acceleration is upward. So here, T1 is going up. So what's going to happen is, here's my little T1 guy. I have an upward acceleration and a downward gravity. They're going in opposite directions, but it's like a tug of war. So what happens is, in opposite directions, you actually add them. So the total acceleration is going to be 10 meters per second squared plus 2 meters per second squared. So in order to find the tension is just the mass times acceleration is going to be 24 newtons. All right, let's look on the other side, on T2. So T2, here's my little guy. Acceleration due to gravity is down, and the acceleration due to the movement is down. So here, both vectors of acceleration are pointing in the same direction. But the downward acceleration is actually alleviating some of the tension caused by gravity. So in this case, I would subtract them, even though both arrows are going in the same direction. I know, it's crazy, but this is how it works. So here, total acceleration is 10 meters per second squared minus 2 meters per second squared is just equal to 8. So the tension is 3 kilograms times 8 meters per second squared equals, hey, is it crazy that both of these are 24 newtons? Should the tension be the same in both of them? Why, yeah, that's how it works out in our favor. All right, there you go.